instruction. We're going to continue logs, and today we're going to look at some properties that allow us to expand and condense logs. So these properties that are listed over here, they're actually going to be pretty similar to what you guys did with your exponent properties. Because if you think about it again, logs and exponents are very related. They're inverses of each other. Well, let's think back to exponent rules. If I had x to the m times x to the n, what I did with those exponents was I added them together. So even though the bases were multiplied, I added those exponents. If I had division, then I could subtract those exponents. So even if the bases were divided, I subtracted those exponents. Then the last property we had with exponents was if I had a power to a power, that was when I multiplied my exponents. Well, all of these properties are actually pretty similar when we start talking about logs. Now the difference here, our multiplications not of our bases, our multiplication here is of the argument. Okay, so if there's multiplication within the argument of a log, you can separate that into two logs that are added. If you have division in the argument of a log, you can separate that into two logs that are subtracted. And then if you have a power raised to a power, then basically you can take that power and move it to the front and multiply it by the entire log. Now this works both directions, and what we're going to do, we'll work on these both ways. We'll work on both expanding and condensing, but if I'm given to start something like this, I can condense it and multiply those arguments together and write it as a single log. Condensing into a single log is going to be really helpful when we get to solving equations later on in this unit. So let's go ahead and start by practicing with just some condensing. All right, so I have addition here. I am adding these two logs together. Well, if I'm adding two logs together, I am multiplying the arguments. Again, the base of these logs does need to be the same in order for this to work. That's a point I forgot to bring up. But if you notice, okay, in both cases, they all have the same base. That base does need to be consistent. All right, so now let's look at the next one. What I like to do first, any numbers out in front, I think it's easiest to go ahead and move those as exponents. So I'm going to take that 3 and make it the exponent of that log's argument. So this would become log 2 to the third. Now at this point, if I have 9 times 8, that would become log 72. And now I'm subtracting these logs, so I'm going to divide the arguments. Now, a really common mistake that I see here is a lot of people will write this as log 72 over log 3. Okay, keep in mind, we're not dividing the logs, we're dividing just the arguments. So I'm only going to do 72 divided by 3. My goal is to get this as a single log. 72 divided by 3 would give me log 24. All right, if you feel comfortable, pause the video, try this next one. All right, so 1/2 becomes an exponent, 2 becomes the exponent on the y, 3 becomes the exponent on the z. So this becomes log of x to the 1/2. Now remember, x to the 1/2 power, that does mean the square root of x. Then this becomes log of y squared. This becomes log of z cubed. Now, some people get a little bit confused on this when you have this division twice, okay? Another way you can look at this is if I factor out that negative, it's really minus both of those two things, which would then be multiplied together. So because you're dividing both of these logs, both the y squared and the z cubed will be in the denominator of your condensed log. So this will be the square root of x over y squared z cubed. So basically, if it comes after a subtraction sign, that argument is going to go in the denominator. All right, then our last one. Now, there's a really important thing we need to understand about logs. A log, the argument, is not multiplied by the log. This does not say ln times a plus b. Okay, that is not what's happening here. So since those aren't being multiplied, you're actually taking the log of a plus b. You can't have just ln by itself. It doesn't exist. It has to have an argument that goes with it. So what you cannot do is distribute. And that's what a lot of people want to do. They see ln and they see parentheses, so they assume, okay, let me distribute. But that does not work for a lot of reasons. First of all, we just talked about that property. Okay, the natural log of a plus b, the natural log of a plus the natural log of b is not this. We just talked about that. You would multiply those arguments together, and that's what you get. Okay, so we cannot distribute to an argument. That also is true later on in pre-cal when you guys get to your trig properties. Okay, I can't just distribute sign to both of those things. All right, there's going to be a much longer process that you guys are going to learn to deal with that. All right, now what I can do here, I have two logs that are being added. Well, if I have two logs that are added, then I can multiply the arguments. So a plus b times a minus b, that's a difference of squares. That 2 I'm going to move as an exponent. And now I have two logs that are subtracted. So now I can move that c squared into the denominator. All right, now we're going to go the opposite direction. We're going to expand. Now, expanding is going to be helpful whenever you're given kind of a table of a few types of log values and you need to evaluate based off that table. And we'll do a couple of those examples here in a little bit. But that's when the expanding process is really going to help us. The condensing process is going to be really helpful when we start solving equations later on. Okay, so again, you can do this in multiple steps. You can do this in one step. I'm going to show it in multiple steps just to kind of get the process down. Now, the easiest place to see where to split this is going to be at the division. All right? Anytime there's division in the argument, that becomes subtraction of a new log. Well, now we want the simplest log possible, or simplest argument possible. So here, that's not the simplest possible because this is 5 times x to the 7th. So I'm now going to separate that multiplication into logs that are being added. Then I still have one last step. I can take that exponent and I can move it to the front. So I'm going to rewrite this as 7 ln x minus ln y. And what that does, that gives me the simplest possible argument for each of these logs. All right, if you feel comfortable, pause the video and then try this next one. Okay, so remember, this is 3 times x to the 4th. So I cannot, a common mistake here is a lot of people just want to go ahead and move the 4. I cannot move the 4 because the 3 itself does not have that exponent. Also, guys, I apologize. I really should have parentheses so you know what that argument is, but I did not include this when I typed it. All right, so again, the 3 does not have the 4 as an exponent. So I can't move the 4 and keep it on that whole argument. So what I need to do first is separate this out and make this log base 6 of 3 plus log base 6 of x to the 4th. So then I can go ahead and move the 4 to the front, and I have my simplest arguments possible. All right, C twice apparently. Again, I'm going to go ahead and start by separating it where there is subtraction. Now, there's two different ways that you can write your answer here. I'll go ahead and show you both, but I'm going to go ahead and separate this on its own first. Now, this is not the simplest answer because, again, we have multiplication within the argument. So I'm going to change that into addition. What I need to be careful of, though, I'm subtracting this entire log. So when I separate this, I need to include parentheses. Because, again, both of those things are in the denominator. The other way that you could write this, what we talked about, if it's in the denominator, it's going to follow after a minus. So either of these versions is okay, whichever one's just the simplest for you, and is going to help you kind of get where you're going for the point of the problem. All right, last one, let's look at D. Okay, so log base 5. The square root of x, okay, square root of x minus 1 over x plus 1. I'm going to start by moving that square root of x, because there's square root. Remember, square root is the same thing as 1/2 as an exponent. Now, since both of those terms, or both of those expressions are under that radical, they both have that exponent. So I can go ahead and move that 1/2 to both of these. Then there's division in the argument, so I can separate this into subtraction. And then I can write this one of two ways. I can put parentheses here and do log base 5 of x plus 1, or I can just rewrite the 1/2. At this point, this is as simplified as you can get. Again, when you have addition or subtraction within the argument, there is no property that deals with that. You cannot distribute, and there's really nothing else you can do. When we get to solving again, you're going to see this come up a little bit more, and we'll work with that. All right, so again, the reason that expanding process is helpful is for questions like these. So what we know that the log base 3 of 4 is approximately that decimal. The log base 3 of 5 is approximately that decimal. All right, so what we need to do is use that information to determine log base 3 of 4/5. So what I need to do is I need to write log base 3 of 4/5 as a similar expression using the logs that I already know. Because I don't know 3 to the something power equals 4/5. I don't know what that is. It's going to be a decimal. So we're going to assume we don't have a calculator in order to be able to evaluate these. All right, so what we're going to do is I'm going to rewrite this as log base 3 of 4 minus log base 3 of 5. So then what I can do, I know log base 3 of 4 is 1.262. Log base 3 of 5, 1.465. And then from here, I can go ahead and evaluate this. And that's going to give me a negative 0.203. Now, if you were to actually evaluate this log with a calculator from the start, you would get that same answer, just a longer, more accurate decimal. This is kind of the rounded version. But this process really is helpful because what you're going to see a lot of later on is you're going to see these kind of things, but you're going to have variables in the place. So even though you can evaluate it with a calculator, you need to make sure you understand the process, because once we get those variables in there, it's going to be a little bit harder to work out. All right, so let's look at B. So I need to come up with a way to get this based off of those logs. Well, 100 is the same thing as 4 times 5 times 5. So I can write this as log base 3 of 4 plus log base 3 of 5 plus log base 3 of 5. Well, now I have 1.262 plus 1.465 plus 1.465. Add those up, and that gives me 4.192. All right, so now let's look at log base 3 of 25. Again, I can do this actually two different ways. I could do log base 3 of 5 plus log base 3 of 5. Another way I could do this, though, this is log base 3 of 5 squared, which means this is 2 times log base 3 of 5, which means this is 2 times 1.465, which is 2.93. All right, let's look at log base 3 of 1 over 16. So this is a case where it may be easier to use exponents. 1 over 16 is the same thing as 4 to the negative second. So this is negative 2 times log base 3 of 4. So this is negative 2 times 1.262, which gives me a negative 2.524. All right, let's look at log base 3 of 1 over 20. All right, so again, couple different ways that we can work this out. This is going to be, I could do log base 3 of 1 minus log base 3, we'll go ahead and put parentheses, of 4 plus log base 3 of 5. So that's one way I could work this out. Now, you might be looking at this and thinking, but log base 3 of 1 is not listed. Well, log base 3 of 1 is not listed, but log base 3 of 1 is something that I can really easily evaluate. 3 to the something power equals 1. Well, anything of the argument of 1 is 0. So this is 0 minus 1.262 plus 1.465. which gives me a negative 2.727. All right, the last one, a little bit harder to see because if you think about just 4 and 5, it's kind of hard for me to get to 12. Well, let's look at what we know. We know log base 3 of 4. Well, 3 times 4 is 12. So I can rewrite this as log base 3 of 4 times 3. So I can separate that into log base 3 of 4 plus log base 3 of 3. Even though log base 3 of 3 is not listed in my chart, I know log base 3 of 3. 3 to the something power is 3. That's 1. So this is log base 3 of 4 plus 1. This is 1.262 plus 1. So this is 2.262. All right. So the last thing we're going to look at is something called the change of base formula. Now, back before our calculators could actually change the base, this was a really important formula to use, but now in the newer operating systems, you do have that change of base option. This is still a helpful property, though, when it comes to simplifying expressions. So the way it works is you could take a log of any number and rewrite it as any base that you want to as a quotient. Now, when we say any base, typically the bases you're going to use are the common log or the natural log. So common log, again, is base 10. Natural log is base e. So the way it works, you would rewrite, so let's say this was your original given log. You would rewrite it as log of any base. So again, this could just be regular log. So it's the log of the argument divided by the log of the base. And that's how we can rewrite it. So let's look at an example here. Log base 3 of 8. So I could rewrite this as log 8 divided by log 3. And I can use that, and I can go ahead and evaluate that in a calculator if I want. But what's important to understand is that those are equivalent. One thing that is really helpful to know is, again, this is not the same thing as the log of 8 over 3. Okay? Remember, the log of 8 over 3 is log 8 minus log 3. All right, looking at the next one, I could write that as log 11 over log 7. And again, go ahead and evaluate a calculator if you want to check. You can check to make sure either way you type this in, you're going to get the same decimal, which is, I need to plug it in. Both of those will give you 1.232. And again, you can use any base you want. Now, typically, we're going to use the common log or natural log because those are the buttons you kind of have on your calculator to make it easy. So let's just go ahead and use natural log. I could rewrite this as ln 8 over ln 3. And I'm still going to get the same decimal, which is 1.893. All right, and again, I can write this as ln 20 over ln 2. Now keep in mind, again, this is not ln 10. Okay, I cannot just divide those arguments like that. This is a log that's divided. The argument is not divided. It's a really important distinction to make. Again, the more important distinction, though, a big reminder, okay, cannot distribute. Don't distribute to the argument of a log. That's a really important thing to understand. You guys remember one of the things that we talked about with inverses. If two functions are inverses of each other, then if I do composition, f of g of x is the same thing as g of f of x, and both of those things equal x. Well, let's say that f of x is log base b of x, and let's say that g of x is b to the x. Well, we know those two functions are inverses of each other. We've talked about that before. So what I'm going to do is I'm going to go ahead and actually do those two things to show you these inverse properties. So I'm going to do f of g of x. So that would be log base b of b to the x. Well, log base b of b to the x, because this is a composition, because those are inverses, that's going to equal x. Well, we also know, using those properties from last week, if I do x times log base b of b, log base b of b is just 1, which also gives me x. Okay, so that's true for two reasons. But knowing that it's true because of these inverse properties helps us to see this other one. If I do b raised to the log base b of x, because again I'm doing g of f of x here, Well, g of f of x also has to equal x. So b to the log base b of x is also x. So let's look at some of these practically. All right, let's look at 8 to the log base 8 of 4. Well, because the base and the base are the same there, 8 to the log base 8 of 4 is just 4. That's that inverse property. All right, then we'll look at this next one, okay? Log base 7 of 7 to the negative 3x. Now, you could work this out using the properties that we did last week. You can move that exponent to the front. Log base 7 of 7 is just 1, and you get negative 3x. But if you didn't want to show that work, you also could just use that inverse property, which tells you that exponent right there is going to be your answer. Again, that is considering, though, that this base is the same number as the base of that exponent there. So those numbers do need to be the same. All right, same thing on the next one. Again, the bases need to be the same. Well, this is e, and ln does have a base of e. So since those bases match, I get 20. So then what we need to consider is what happens if those bases aren't the same. Well, if those bases aren't the same, we have a couple options. So one option is I can rewrite the base so that it is the same. For example, on this one, in order for me to use that property, this needs to be a base of 2. Well, I can rewrite 8 as 2 to the third. That's now multiplied by log base 2 of 7. Well, now again, my answer here, though, is not going to be 7 because I have that 3 out front. So this would become 2 to the log base 2 of 7 to the third. So my answer here would be 7 to the third, which is 343. All right, let's look at this next one. So this one's a little bit different. Now, it's kind of hard to rewrite. I can't write 8 with a base of 4. And it's going to get really messy if I try and write this base as 2 squared. We don't want to get into that. What I can do instead, look at the log that you have here. Log base 4 of 4 is something that we know. Log base 4 of 4, okay, again, just look at that independently. 4 to the something power is equal to 4. That something power is 1. That means log base 4 of 4 is just 1. So this whole thing is just 8 to the first power, which is just 8. All right, and this last one, very similar. The base is already matched, but again, I do need to take care of that 3 and move it. So this would become e to the natural log of 5 to the third. So my answer here, because e and e, same bases, my answer would be 5 to the third, which is 125.